Trying to understand behavior of small particles in the cell using established methods is like trying to understand humanity and not being able to see anything smaller than a city block. The 2008 Nobel Prize for Chemistry was awarded to scientists who've created fluorescent proteins that are lighting up the cell from the inside. Fluorescent proteins work the same way as bioluminescence in jellyfish. The applications of this are already exciting. Scientist Xiaowei Sheng at Harvard University is bypassing the limits of light, allowing us to watch live molecules in action for the first time. Xiaowei's team is intent on tracking individual viruses as they infect the cell. To do so, they use fluorescent proteins to illuminate cellular structures and fluorescent dyes to light up individual virus particles. It's like hanging tiny lanterns in the cell. Then they hit the cell with a laser, and the lanterns light up. But because the lights overlap, it's impossible to discern what's what. It's not enough just to illuminate the whole cell. In fact, the biggest innovation that Xiaowei brings to the use of fluorescence is isolation. Xiaowei's microscope apparatus, called STORM, has a laser strobe light that flashes in milliseconds. In the cell, photo-switchable fluorescent probes flash on and off in 10 different colors. During the light show, Xiaowei's team records super slow-motion video and then pores over the results, painstakingly going frame by frame to pinpoint and identify individual spots of light. Instead of 30 frames per second, they are dealing with more like 30,000 frames per second. The glow cast by a fluorescent molecule extends for approximately 200 nanometers, which is about as small a thing as you can see using light microscopy. Once the glow is isolated in time and space, Xiaowei can be sure that in the center sits a much smaller target, a molecule, protein, virus, or otherwise. She marks the actual position of the target with a dot. Finally, the computer reconstructs all of the dots into an accurate portrayal of life on a scale we've never seen. Electron scanning, infrared, and other methods developed over the past half-century can resolve smaller objects. Trouble is, those high-tech viewers also kill what they're looking at. Only light is gentle enough to view life, and therefore to observe behavior. Xiaowei's work marks a new frontier in imaging inner space. The scientific community has already taken notice, and Nature has named it Method of the Year. It will be exciting to see which mysteries come into focus once we can observe the behavior of molecules.